what fundamentally changed things is when those online maps became online maps that we accessed on our mobile devices. And the mobile devices brought that capability with the very first GPS capability. So that was a big shift because it suddenly put you on the map. It put your location in the center of the map, and you no longer had to work out where you were.
Welcome to another episode of the Mapscaping Podcast. My name is Daniel, and this is a podcast for the geospatial community. Today on the show, we're going to be talking about where the blue dot comes from. How does your cell phone, how does your mobile device calculate its location? It's not quite as straightforward as you might imagine, and my guest on the show today, Ed Parsons, Google's geospatial technologist, is going to help us understand where the blue dot comes from and how it's calculated. So I think this is a really fascinating episode. I really enjoyed talking to Ed about this, and I really hope you find it equally as fascinating. If you're like me and really into this kind of stuff, I'll put a few links in the show notes of this podcast episode to previous episodes that you also might enjoy. Okay, here is Ed Parsons, Google's geospatial technologist. Hi Ed, welcome to the podcast. It's an absolute pleasure to have you on today. For every podcast episode, I do this pre-interview, and it was fascinating talking to you during the pre-interview, so I'm really looking forward to this recorded conversation. Today, we're going to be talking about where the blue dot comes from. You work for Google, and you know a lot about this, calculating the location of a device. And I think before we dive into all that, perhaps you could just briefly introduce yourself to the audience and explain where you are in your career now and how you got there.
Yeah, thanks, Dan. So I'm Ed Parsons. I'm Google's geospatial technologist. I've been at Google nearly 15 years now, which is quite a long time for anyone to be at Google, almost as old as Google is, I guess. Previous to that, I was, I suppose, much more a traditional company. I worked for the Ordnance Survey, the national mapping agency here in the UK. Before that, I worked for other American software companies. And originally, I was an academic. I set up a course that taught geographic information systems, one of the first courses that did so at Kingston University.
Oh, you've come a long way in your career. Just out of curiosity, was that a big jump for you to come from the public sector into the private sector?
Oh yes, yeah. I used to joke that it gave me sort of cultural whiplash. The change was pretty intense. It wasn't a surprise because the culture, the ethos of the organisations is very different, and I had the expectation it would be very different. But yes, it was. There's much more flexibility. There's much more agility, I think, in the private sector. And particularly then, Google was a younger company where we were more agile. We did things even more quickly than we do now. But I'm not saying one's better than the other. If you work in the public sector, the taxpayer is your boss, and you have to make sure that you do things in a steady and well argued way.
As a company like Google grows, you mentioned the word agile there before. I mean, obviously, when they're a young company, they can move really, really quickly. And we often hear this idea of move fast and break things. How do you see that changing as the company grows? Do you see it moving more and more towards like sort of the public sector kind of culture?
I think you have to put more controls in as you get larger, just to manage things. I think there is still an element of that sort of startup ethos within Google. I think everyone wants to keep that, and I think even internally the idea of sort of having different project teams sort of almost competing with each other to try and solve a common problem is still there to a lesser extent than there once was. But I think it's just a natural result of an organization growing in size. You have to put in place more processes just to manage what's going on.
Well, thank you very much for this sort of brief look into your background and a few of your thoughts around like that move from public to private and what Google looks like today and perhaps where it's going in terms of its culture. I really appreciate that. The promise at the start of this podcast is that we're going to be talking about where the blue dot comes from. So in a previous conversation, you mentioned this idea of the fused location service, I believe you call it. Perhaps we could start with that and then sort of break down the pieces that go into that make up this fused location service on Google devices.
Absolutely happy to do that. And maybe even step further back and just to set ourselves that sort of paradigm shift that the blue dot represents. I think we've all sort of grown up with web mapping and mapping online. And, I'm old enough to remember that kind of big transfer to the early web map services, the MapQuests, the multi-maps, which were a big jump, but they really just took existing paper maps or simple cartography and they put it online for people to use. what fundamentally changed things is when those online maps became online maps that we accessed on our mobile devices. And the mobile devices brought that capability with the very first, I guess the Nokia N95 was one of the first phones that had this with GPS capability. So that was a big shift because it suddenly put you on the map. It put your location in the center of the map, and you no longer had to work out where you were. And that's what, the blue dot represents. And for most people, they still think in terms of, the blue dot, that's my location that comes from GPS or this thing that's called GPS. We may not completely understand how GPS works, but nevertheless, the blue dot represents my GPS location. In reality, the blue dot represents quite a lot of complex technology and different services and systems that are running both on your mobile device and maybe running on the network to help locate where you are. And this is where the idea of, if you mentioned, the fuse location comes from. The blue dot actually represents your location that comes from a number of different mechanisms, a number of different systems at any particular time or at any particular location, presents your location to the best of the device's ability. And that's constrained by a number of factors, by the ability to receive radio signals, depending upon where you might be, but also it's largely dependent on the power requirements of those different services. One of the big tasks anyone designing a mobile phone application that uses location is around power management, because GPS itself is a technology that requires an awful lot of power to operate all the time. And I remember in the early days of having an N95, if I had the GPS switched on all the time, the phone battery would run out in literally an hour, completely impractical. So we've had to work quite hard to get beyond that.
Yeah, and I think when we think about GNS, for example, we've come, obviously in terms of power consumption, we've come a long way. When do we use it? When do we not use it? But also in terms of constellations and the accuracy that's available through that. Are we still talking about a single constellation, GPS, or are we talking about all of the constellations now when we think about understanding where we are through our mobile device?
In most cases, we are talking about the various constellations that are out there. So that's GPS from the United States government, it's GLONASS, which is the Russian system, it's Galileo, the European Union system, the Beidou, the Chinese system. There are also local systems emerging, in India and in Japan, and they're all finding their way into our phones because they basically use the same technology. They use similar frequencies, and a chipset that's in your phone will be able to receive signals from all of those. And so although we talk about GPS, you're right, actually we're talking about GNSS, Global Navigation Satellite System, and it's a multitude of those different systems. You'll be getting different signals from different constellations of satellites all at the same time, and the device will be managing all of that. So, although you call that GPS, actually it's already much more complicated than the simple label will make it appear.
So this is one of the things that goes into this fused location service is the GNS access to these different constellations, these signals that come from them. So yeah, already it's hugely complicated. Can you talk a little bit about the Wi-Fi database?
Yeah, well, let's maybe start from the ground up. So initially, your mobile phone will know where it is, and every mobile phone that we use today has to know where it is because it's a fundamental constraint of mobile networks. Is if you just think about it, if someone dials your mobile phone number, the service needs to know which is the closest cell tower to your location to route the call. So at a very base level, every phone will know where it is because the mobile phone network maintains a rough location of where you are in relation to the cell tower. So that's the very kind of bottom level, if you like. So that's part of how you might identify where you are. So your cell tower is giving you the coarsest resolution, the coarsest accuracy of your location. You can build on that with then GPS, and that's what everyone kind of thinks the blue dot mostly represents. But one of the issues with GPS, as I said, is power management. Also, you need basically a clear horizon to the satellites. You need a line of sight to the satellite that's providing you in effect with a timing signal. And if there's something between you and that satellite, a tree, a building, a mountain, you're either not going to get any signal at all, or you're going to get a signal that has been bounced around and is not necessarily giving you accurate timing. So in many circumstances, GPS isn't necessarily the best technology to use. So pretty early on in the development of smartphones, a number of different other technologies were looked at. And one of the ones that I think is probably actually the most widely used and perhaps least understood is identifying your location based on proximity to Wi-Fi hotspots. So, we all live in a world now that is connected via Wi-Fi devices, either at home because we have home broadband that is being served via a Wi-Fi hotspot that powers all of our devices at home, or in public places, in railway stations, airports, coffee shops. There are Wi-Fi hotspots all over the place. Each Wi-Fi hotspot has a unique identifier, its MAC address. It's part of the network infrastructure of the internet. And we can, in effect, map a Wi-Fi hotspot to a particular location and then build a database of those Wi-Fi hotspots and locations so that your mobile device, if it is connected to a particular Wi-Fi hotspot, we can then work out, well, which Wi-Fi hotspot is this? What location do we have for that Wi-Fi hotspot? And use that as a mechanism of providing the device location. And that's actually a very robust mechanism. It's a very efficient in terms of power consumption because you've always got your Wi-Fi switched on your phone most of the time, because that's in many ways the way that you're accessing the internet anyway. So that's a great robust mechanism. And as I said, in many cases where you think the blue dot is giving you a location coming from GPS, it's actually this Wi-Fi technology that is identifying where you are.
How does the phone know where the Wi-Fi is? Is this saying I identified, I can see a Wi-Fi network, and then sending a query to Google somewhere and saying, I can see this, where is that, and getting it back? Is that the way this process works?
No, in effect, you will have a database on your device that is a database of Wi-Fi hotspots and their locations. So there's no need to have a sort of conversation with a network service to do that translation, because it's been in effect cached onto your device. And that works the same way whether you've got an Android phone or an iOS phone. There are a number of providers of these databases that match Wi-Fi hotspots to locations. And it's surprising how small that you can do this, and you then just need to keep that database updated, because clearly Wi-Fi hotspots change and they kind of move around a little bit. And sometimes you might have noticed this, that you switch on your phone and initially it seems to say, well, you're actually in Edinburgh when you're in London. That could be just the simple fact that it picked up a stale Wi-Fi hotspot that has moved, and there's an element of error correction that goes on your device to say, well, actually, if your Wi-Fi hotspot is saying this, but your cell tower is saying something else, maybe we need to check this. And that kind of goes on behind the scenes to make sure that you get an accurate blue dot. So your blue dot may then suddenly shift to the actual location because we've disregarded a stale Wi-Fi hotspot.
Okay, so we've got this, we take the location from our cell towers or the proximity to the cell towers that we're connected to. We've got GNSS available to us. We've got this Wi-Fi database that lives on our phone, so the device can quickly identify the Wi-Fi hotspot and its location and help sort of narrow things down there. What else can we do to help sort of create a really accurate and precise position from our phones?
Well, those are the three main technologies that are used at the moment. And that fused nature means that the choice of what particular technology is used at any particular point in time is largely invisible from the user. And in many cases, it's invisible from the application developer. So if you're building an application on an iPhone or an Android phone and you want location, you make a single call to the operating system, and the operating system will decide what's the best technology to provide the location that you need. And you can say, well, I need a precise location, or I need a relative location for my particular application. So it's probably only if you're doing turn-by-turn directions that you'll have your GPS switched on, because you need that precise location all of the time. So we then start to get into some of the edge cases where it might be, well, okay, even though you've got Wi-Fi and you've got GNSS and you've got these other technologies, what are the other problems that we might need to solve? And one that I'm particularly keen on is the idea that we've come up with called visual positioning. And that's the idea of saying, well, one of the key issues you might have from a urban mobility point of view is you're traveling on a subway system in London or Sydney or Tokyo or wherever. So your phone has largely been hidden from GNSS because it's been down in a tunnel. The phone itself has sensors, things like inertial navigation or inertial measurement units, so accelerometers. It has a digital compass in it, but they get impacted by RF radiation. So they will have been impacted by the fact that you're on an electric train running in a tunnel. The end product, the end result of this is when you come out of a metro station or a tube station, you pull out your phone really struggles to identify where it is. And if it does identify where it is, the next issue is what we call pose, i.e., which direction am I facing as I come out of the tube station? And we've all done the kind of embarrassed dance, I think, when you come out of a metro station and you start walking off confidently in one direction, following your directions your phone is giving you, and then suddenly you realize, oh no, actually that was the wrong direction, and then you do 180 and you go off walking in the opposite direction, and you try to make it look like that was the choice you were originally. And the product, that's the result of this kind of immediate confusion of being out of any signals, being a little bit confused by all of the RF shenanigans that are going on in the metro station, and suddenly emerging onto the street. So what we came up with is this concept of, well, Google particularly, we have a resource in terms of the street view imagery that we've captured over the last decade or so around the world. So we know what neighborhoods look like. We have the outlines of buildings and so on. So we developed a capability on Google Maps for Android and just rolled out recently in iOS to do what we call visual positioning. And that is basically to use the camera of your mobile phone to sense the environment around you as you come out of the tube station, for example. In effect, compare the picture that the phone camera is seeing with our database of what the streets look like, and then use that to orientate your device. And when you can use that methodology to orientate your device when you're doing any kind of pedestrian navigation, there's now a capability in Google Maps, if you're walking, to use the visual positioning system, to use the camera of your device to supplement GNSS and all those other technologies giving you your blue dot, to not only identify whereabouts you are, but also to identify which direction you're heading, which way are you moving, and compare that with the environment around you, and then overlay on that using simple augmented reality directions. So we put the directions onto the roads that you're walking or onto buildings where you need to turn left and right. So again, that's an additional capability that's kind of sits on top of where your blue dot is. The next problem you're trying to solve is, okay, your pose, which direction are you heading in?
Wow. I mean, that is just amazing. It's mind-blowing to think about how much processing power you need to be able to offer a service like that. It sounds incredible. Is this one of the few, I guess, tools that we can use that if we're standing still, that's going to solve that location of pose and orientation, or are there other things? Could you use dead reckoning, for example? I believe you talked about an inertial measurement unit in the phone. Could that also help solve the problem of what orientation does this device have?
It can, to a certain extent. The trouble with the inertial measurement units you have on your phone is they're relatively cheap. They're not what an airliner or a missile might have, but they work reasonably well for a short period of time. Creep tends to occur after a while. But you're right to kind of sort of drill into that as an interesting area, because it's probably the next real area of innovation and development, because we want to be able to take our ability to kind of navigate the world into buildings. And when you go into buildings, you immediately lose GNSS as a mechanism. The other technologies in terms of Wi-Fi and cell towers are probably not, well, they're not precise enough to allow indoor navigation. So you start to use other technologies. There's a development of Wi-Fi, the Wi-Fi standard, that allows time of flight measurements of the Wi-Fi signal. So it will turn, if you like, your Wi-Fi hotspot into a pseudo GPS satellite, because it will broadcast not only your Wi-Fi signal, but also a timing signal, which you can use then to measure quite precisely the distance from your device to that Wi-Fi hotspot, and then do triliteration the same way that you would do with GPS. So there's an emerging capability to use the next generation of Wi-Fi hotspots as almost GPS services. There are other technologies you might need to use that are more about proximity. So there's been a lot of interest over the years around Bluetooth LE sensors, and they're very good to say, well, actually I'm in this particular room because I can sense there's a Bluetooth sensor there. It's always more complicated doing mapping or location determination indoors, because any indoor space is a private space. It's owned by someone who has, control over access to that, and have control over the infrastructure that is put in place. There are solutions that use, technologies like ultra wideband in industrial solutions. If you're, in a factory, you can put ultra wideband infrastructure in your factory and put ultra wideband receivers on your tools to make sure you know very precisely where every tool is in the factory. It's really, really costly. But if you lose a screwdriver inside the wing of an Airbus, that's pretty expensive to get it back out again. So kind of that makes sense. It's more difficult to see that scaling up for mass market applications. There's a lot of interest in that visual positioning service I was mentioning earlier in indoor environments, particularly complicated ones like railway stations and airports. And we've experimented using visual positioning services in some railway stations in Tokyo that are particularly complicated to navigate. They're very complex 3D structures to navigate through, and visual positioning is a mechanism that does work indoors.
Yeah, I've got a couple of questions here. I'd like to stay with the Wi-Fi one just for a second here. If we move over to that standard that you're talking about that allows for time of flight measurements, are we going to be facing the same sort of multi-path problems that we see with GNSS?
Yes, but to a lesser extent, and again, bringing that multipath up is a good segue into another innovation that we've been looking into. And again, it's related back to that fact that we have now a reasonably detailed model of most urban environments that we capture through photogrammetry and having those street view vehicles. So, part of the problem is if you're in an urban environment and you're reliant on GNSS signals, a big issue is multipath, and that basically is your signal coming from the GPS satellite is bouncing off other structures, so that the time that the signal is taking to get to your satellite isn't the real time. It's being extended a bit because the signal has bounced around a little bit. And, we're talking very tiny amounts, but those tiny amounts make a difference in locating yourself. And you may well have noticed if you've just tried to use GNSS in an urban canyon that you might well have been located on the wrong side of the road to the side that you're actually on. And that's a result of this multipath. Now, because we know where you are approximately, and we know the morphology of the neighborhood you're in, i.e., we know where the buildings are, we know the trees are, we can use that data to, in effect, model what we expect the multipath errors to be and to cancel them out. And that's a mechanism that we've started rolling out. If you bought a Pixel phone in the last year or so, and you're in one of the major cities of the world, your location will be being corrected for multipath by using this sort of city morphology model to try and correct for the multipath. And it does work, and it works, to the extent that we will, with a much higher level of likelihood, get you on the right side of the road to an actual location. So, all of these technologies are kind of building on top of each other to improve the reliability of your location, and to do so in a way that isn't draining the battery of your phone, and is making good use of the capabilities of your device, depending upon what you're doing. Because there's another important question here, which is about, well, how precise do I need to know my location for the particular use that I'm wanting to do? Clearly, if you're doing turn-by-turn navigation as a pedestrian, you need to know probably quite precisely where you are. But if you just need to know where your local Starbucks is, you don't need a precise location to do that. If I get you on the right street, it's probably close enough. If I want a hyper-local weather forecast, just to be able to identify what neighborhood I'm in is enough. And that's where technologies like Wi-Fi are really, really valuable, because they consume very little power, and they can give you a reasonable level of location accuracy for many different types of application.
I want to come back and sort of tie what you just said back into this fused location data service in just a second. But before we move too far away from this, I want to make sure I've understood this correctly. So Google is creating these 3D models of popular cities, I believe you call them. And is that being stored on our phones in the same way the Wi-Fi database is being stored on our phones? Or is this, again, of making queries across the network?
Again, we'll try and cache as much of that content on your device as possible. So kind of the level of resolution that we need, we can build relatively small databases that sit on your smartphone that can contain the morphology of the city that you're within. We couldn't have the whole of the world in 3D on your phone, but we can do it for kind of the local area that you're likely to be in while you're in that particular area. And it's a similar methodology to the Wi-Fi databases you use. But then don't forget, the device you're carrying around in your pocket is an incredibly powerful computing device. We end up using them for social media and taking pictures of, of stuff, but actually they're really powerful computers with a great, ability to do a lot of processing and to store, quite large volumes of data. So yeah, don't be surprised about the capability your smartphone has.
Actually, I'm constantly surprised about the capability my smartphone has. Is this the same for the visual positioning system? So I believe you used a example of commuting in Tokyo in Japan down through the subways, through the metro systems there. Let's say I've got to commute to a new place in the morning. So I go into Google and say, well, this is where I am and this is where I got to be. It calculates a route. I think that's great. I'm going to follow that. Will it preemptively download some of those images onto my phone in the same way that to store some Google Street View images onto my phone so I don't have to access the network when I'm underground, for example?
Not currently. That's largely a result of the way the division between capabilities that happen at an operating system level and capabilities that happen at an application level. So at the moment, the visual positioning thing is an application level thing. So it's something that happens within the Google Maps application, and it only works when you explicitly press the button in the application, and it then starts to do network comparisons between what the camera is seeing and what we see the world to look like. So that's something that it's not an operating system level capability that's kind of embedded and cached onto your device. That's something that does require network traffic and talking to cloud-based services.
Do you see a place for something like peer-to-peer networking or mesh networking in terms of figuring out or calculating the location of devices?
Hmm, good question. I mean, I think, if you think about it, for peer-to-peer, for mesh networking, location is an important part of that because, for meshes to work, they need to understand the topology, the location of the devices. And particularly you look at sort of beamforming on devices now, relative location's important. I'm not sure necessarily the use case of that working in the opposite direction, other than the sort of time of flight calculations that you might want to make use on, the next generation of 802.11 devices. So interesting. There's probably potential there. I remember, maybe 10 or 15 years ago, there were a couple of startups that tried to do peer-to-peer location determination just because GPS was expensive both in power and cost terms at the time, and maybe you could link devices together that knew where they were. I'm not aware of any kind of current thoughts in that direction, but yeah, there might be something there.
So I was talking to a company a wee while ago, and they were developing this application for firefighters when they go into a building. And the idea was that they could work as teams, and they would basically form this mesh network. And they had different ways of calculating the location of each member in the team. But I thought it was fantastic that it was a mesh network. So if one was standing outside and they had a clear sky view, they could calculate a really accurate location based on GNSS and then use that to update everybody else in the mesh network. I thought it was absolutely brilliant.
I think there is something to that, as you say, and I think that there is a lot of interest in techniques that try to make GNSS more robust. There's a lot of concern, quite rightly at the moment, that the technology of GNSS is relatively fragile. It's very easy to spoof GPS receivers. The signal you're getting from a GNSS satellite, because the distance the satellite is away from the Earth, is relatively weak. So there are lots of people looking at, well, are there other terrestrial solutions that we can use to supplement GNSS? Could we use low Earth orbit satellites to supplement GNSS? And that all, I suppose, from your discussion there, kind of that kind of peer-to-peer idea, where in effect you're amplifying signals and using those to sort of rebroadcast location with a stronger signal in a more local environment. So there's certainly a lot of interest in that. So I guess, yeah, that comes back to that use case you were talking about.
Yeah, and to follow on from that, you talked about satellites in low Earth orbit. I've heard, like, I can't, say the name of the company, but I've heard about a company and their idea is to create just what you're talking about, except they are going to be like a signal boost for a GNSS. So they're going to collect the GNSS on their lower Earth orbit satellites and then boost it out.
Yeah, there's a couple of companies looking at doing that, and it's certainly feasible from a technical point of view. I think the practicalities kind of need to be worked out yet, but there's certainly interest in that. And you're looking at advances in using GPS in environments outside of the constellation. So I know that I think maybe the Japanese Space Agency are putting a GPS receiver on the moon. Do you think about it as beyond where the GPS satellites are, but nevertheless, you kind of it can work in the same way. You have a different kind of horizon, and the mathematics are slightly different. But there's a lot of research in this space, and you remember, a lot of GNSS is not just about location; it's also about timing. And there's an important role that GNSS services provide in terms of making sure that we're all working on the same timing signal for all of the network devices that we rely on. So, it really is kind of embedded into the modern world in ways that as soon as you scratch the surface, there's GNSS again.
So before we were talking about like when do we need precise, extremely accurate geographic location, and when do we need relative location, proximity? And right at the start of the conversation, we mentioned something called the fused location service. So as I understand it, this is a service on the phone, and it doesn't show me all the calculations that's taking place. It just says here is the location as best we can do. Does that fused location service, will that say this is a precise location? This is a proximity, this is a relative location? Can I ask it to calculate those things? Or is it just, okay, this is the best I could do here? It's precise, it's relative.
Yeah, in most cases, from a user point of view, it's giving you the most precise location we can manage. But there is a level of control that the application developer has that they can say, well, explicitly, I want to get a precise location because I'm doing navigation, for example. But the caveat against that is, well, if you're going to switch these radios on, you're going to drain the battery much more quickly. So there's that decision that an application developer needs to make. But largely we try to make this as sort of transparent as possible and to kind of work out, well, what sort of activity is this application about, and therefore what sort of level of power consumption. And as I said, power consumption is probably the primary decision mechanism in this case. What level of power consumption is appropriate for this? And of course, that then also gets into issues around privacy and the great old use case of, well, why does my flashlight application need to know my location? Well, almost certainly your flashlight application doesn't need to know your location, and you shouldn't be sharing it. So, it's something that we kind of need to balance. We need to make it as transparent as possible and easy and straightforward, but also to put in place some steps to make sure that, location, which is, from a privacy point of view, quite a serious thing to gather and potentially share. We need to make sure that we're using that responsibly.
Yeah, so let's talk about that for a minute. So Google has done an incredible job of making it easy to calculate the location. And it's under this umbrella again of the fused location service in our devices. And we can't see exactly how it's happening, but we get the best it can do, which is amazing. Is there a tension here between a huge advertising company or a company which revenues are basically based on advertising and access to location? We talked about privacy before. Is there any tension here?
Well, I mean, I guess, regardless of your business model, there is a fundamental point which says, why do I need to capture location in the first place? And that's always the first question you should ask. And it goes back to that flashlight example. So your default is, well, you don't need to know where the user is. You don't need to know who the user is, and you certainly don't need to know where the user is. That's the default position. Now, clearly, if you're building an application for urban mobility and you're navigating through a city, then you need to know the location of the user. But you need to, in all cases, minimize that location data that you collect, both in terms of how precise the location is, but also potentially how frequently you collect the information and whether you store the information or not, so on and so forth. So again, it's like almost sort of an onion skin approach. You start from the very beginning to say, do I need to store location at all, or do I need to gather location at all? Then you start to move out from that, saying, okay, if I do I need to store it? Do I need to gather it? And so on and so forth. So that's clearly part of that discussion, regardless of your business model. And then, if you talk about advertising and potentially sharing location data, well, Google, like almost all companies, actually doesn't share location data with any third party because of its sensitive nature. And in almost all cases, we don't actually store that location data associated with users unless they've specifically requested to do so.
Thank you very much for clarifying that for us. I really appreciate it. I want to sort of zoom out a little bit now. So we've talked about how Google calculates location on our devices. And again, fascinating stuff. Really appreciate you taking the time to walk us through that and explain things. Google, in terms of mapping, like when you think about Google and mapping, the mapping industry, is Google still the incumbent?
I don't think, to be honest, I don't think we've ever been the incumbent. And all the technology that I've spoken about, probably other than the kind of the visual positioning, is standard. That's what every smartphone uses, regardless of where you're getting it from. That's kind of how the industry works. And those innovations are coming from Google, from our competitors. That's the sort of ecosystem that is developing. So from that mapping point of view, I don't think we were ever the incumbent. We have competitors in every market on every device, and increasingly, I think it's driven by quite specific use cases, more specific use cases. We can see classes of applications that are designed particularly for urban dwellers, and they go drill into enormous levels of detail around particular cities, and do so at probably a level of detail greater than Google Maps supports. So, I think it's highly variable, and I don't think we see ourselves really as the incumbent. We're very pleased that many people use Google Maps, but we know it's very easy just to press the next button and use another application on your device if it works better.
I think that's a really, really humble way of putting it. And I think Google makes a pretty great product, right? Like I'm amazed at some of the things that you've told me today. I use Google Maps by default because personally, I think it's the best one. Yeah, I don't know how I'd feel if I was a developer building things based on Google products. I really don't know. But as a user, I think it's an absolutely amazing product. I want to talk about another thing that Google is doing, which I think is super interesting. So we're used to the
Well, Dan,
idea.
Dan, can I just interrupt you there? Going back to that, yeah, you're very happy with Google, and you think it would be, someone developing an alternative application would have to think quite a lot about it. Well, you think back in the early days of Google, web search was solved. Web search was solved by companies like Alta Vista and Excite, and no one thought there was the need for someone else to come along and innovate and do what Google did. I think it's exactly the same case in terms of mapping. There are innovators out there. There are ideas that we haven't even thought of that can radically change the landscape for online mapping. And I look forward to that innovation. I want that competition. I want people to try out new ideas that we don't currently do in the maps applications that we're all familiar with, because absolutely there's the potential for new innovative ideas to knock off the mainstream map applications by doing a better or a different job.
Yeah, and I think you talked about niche case examples before. Like, I think that's where the opportunity is, right? To solve very specific problems for very, very specific groups of people. And I don't see one company having a monopoly on that at all.
Absolutely. No, I think you're completely right there, and that's, I think, where it's really interesting, because there, as is always the case, I think, in success in business, if you know the user really well, you can understand the problems and you can solve those problems, then that's where success lies.
I'd like to talk about voice interfacing because Google does this amazing thing, right? Where and we see the same thing with Alexa. Do you have a voice interface? Could you talk about that in terms of location? Because it seems to me that we, instead of thinking about precise location, we come back to the idea of thinking about proximity to things. This is relative to me. When I think about my Google device, it has an application called Google Home. We use things like a Google Chromecast, for example, and it doesn't need to know exactly where it is. It just needs to say, okay, I am in this room. And then it is, I come into the room and says, this device is relative to you. And it's enough. What do you think the use cases could be for precise positioning inside, for example, and the use cases for proximity? Where do you see the line being drawn there?
I think you make a really good case here, a really strong case actually, for the fact that probably we overuse or think too much about precise positioning, where for most use cases, actually, we don't need to know a precise location. And particularly in those IoT, smart home sort of applications. It is really just about proximity. It's about knowing where you are relative to the devices that you want to interact with and gather information for or control. So, certainly most of those applications you talk about in terms of, talking to your smart devices, it controls a lot. It controls the lights that you switch on. You shouldn't have to say, Alexa, switch on the lights in the bedroom, because Alexa will know that you're in the bedroom because it's picked up your voice in a device that's in the bedroom. And likewise, it should know that your bedroom is perhaps upstairs from your living room. So you say, if I'm in the living room, switch on the lights upstairs. It should be able to work that out. And I think it's taking a different approach to location, of saying, well, location isn't just necessarily X, Y, Z, latitude and longitude stored to ridiculous numbers of decimal points. It's actually much more interesting when it's relative location and understanding the hierarchy of location. So knowing that your rooms are inside your house is in your particular neighborhood, which is in a particular city, which is in a particular country. All of those relationships, I guess, topological relationships, if you think back to kind of the GIS courses you might have done, those are equally important. The topology of where we are is, if not more important than, an absolute location in time and space.
Ed, I think this might be a really great time to round off the conversation. I really want to thank you for your time. I've really enjoyed this conversation. It totally blew my mind with some of the things that we talked about there in terms of determining where the blue dot is on a map. Absolutely amazing stuff. Thank you very much for your time. Just before I let you go, if the listeners want to reach out to you or learn more about the work that you're doing, or if you have any resources you'd like to point them towards, where could they go?
Oh, I guess it's relatively straightforward. I was lucky enough to get on most of the social media early on. So I'm Ed Parsons in most places. And as you would expect me to say, if you want to get in touch or find out more about me, just Google my name and you should find me quite high up in the search results.
Brilliant. Thank you so much, Ed. Really appreciate your time.
It's my pleasure. Thank you.
So I really hope you enjoyed that episode with Ed Parsons, Google's geospatial technologist. Personally, I found it absolutely fascinating. A couple of key points for me were that Wi-Fi database, especially the fact that it's being stored cached locally on your device. I thought that was interesting. And also that the multipath solution that they've come up with by storing a 3D model of the city that you're in to help solve the multipath problem of GNSS. I thought that was absolutely brilliant. And then I guess in a very, very close third place, it has to be the idea of visual positioning. I don't know who else could pull that off but Google. So really, really interesting stuff, at least from my perspective. So I've published a few episodes now around this idea of calculating location, and there's quite a few of them, so I won't mention them here. But if you're listening on a podcast player, click on the show notes bit of of this episode, and there'll be links in there to help you discover those episodes if that's something that you're interested in. And that's it from me. That's it for another episode of the Mapscaping podcast. Thank you so much for tuning in all the way to the end. I really appreciate it. As always, you're more than welcome to reach out to me. I'm most active on Twitter at Mapscaping, or there will be a link to my LinkedIn profile in the show notes, along with links to those episodes that I was talking about earlier. That's all in there. So if you want to contact me, that is a good place to start looking. We write some pretty detailed show notes around each episode, and they're available at mapscaping.com, so feel free to check those out as well. Okay, that's it from me. We'll talk again next week. Bye.